Hello all. So today we'll have discussions on one-way analysis of variance, sometimes abbreviated as one-way ANOVA. So with one-way ANOVA, we normally use it when you have more than two independent groups. So it means the groups are 3, 4, 5, and so on, and they are different from each other or unrelated. So when you have something like that, then it means you're supposed to use independent t-test. So we normally say that one-way ANOVA is more or less like a complex form of independent t-test, because with independent t, our focus is on only two independent groups. But with ANOVA, when the groups are more than two and they are different, then you use one-way ANOVA. So let's assume that you have three groups. Group 1, Group 2, and Group 3. These are the key groups that you have, and they are different from each other. ANOVA runs it in such a way that, or analyze it in such a way that it will compare the difference existing between Group 1 and Group 2 separately. Then we'll also compare the difference existing between Group 1 and Group 3 separately. Then we'll compare the difference existing between Group 2 and Group 3 separately. So it means when you have three groups that are different, you will generate three comparisons out of it. When they are four, the comparisons will be more. When you check, I think the parameters, you will get, or when you permit, you get about 6 comparisons when the groups are 4. And ANOVA would run these comparisons all at once. So one would say that, okay, then why don't I use independent t-test and run Group 1 and Group 2 separately, Group 1 and Group 3 separately, and Group 2 and Group 3 separately. So it means you can use independent t-test to run these comparisons. So it means you run 3 different independent t-tests. But the interesting thing about ANOVA is that it will combine the 3 comparisons together and run it at once. Then you get your comparisons. But with independent t-test, you're supposed to do several tests or several analyses. So we normally say that when you use independent t-test or you run independent t-test severally, you are bound to commit an error known as experiment-wise error. Why are we saying that? One thing is you use independent t-test, run it separately for Group 1 and Group 2. You know whatever test that you'll be using, you set your level of significance to be 0.05. And I said the level of significance is related to type 1 error. So you use independent t-test, run this separately. You had 0.05 error. Group 1 and 3, you also had 0.05 error. Group 2 and Group 3, you had 0.05 error. So it means since you use independent t-test and you run independent t-test or 3 independent t-tests, you had an error which was around 0.15. But when you use one-way ANOVA, ANOVA will merge all of these comparisons together and run it at once. So it means you using ANOVA to run it at once, you are setting your error to be only 0.05. So this is the essence. You use Anova to run all your comparisons. You had and you committed an error which was around 0.05. Then again, you use another test, independent t-test. Use it separately. Run independent t-test for this, run another independent t-test for this comparison, run another independent t-test for this comparison. And you committed an error 0.05 each, which is 0.15. And you can see that the error that you have when you use three independent t-tests or you run three independent t-tests, the error that you are bound to commit is around what? 0.15. But when you use one-way ANOVA and run it for all, or run it simultaneously or concurrently for the comparisons, you get 0.05. As a researcher, our goal is to make sure that the error that we are committing is minimal. Hence, any researcher will go in for a test that will reduce their number of what? Errors. Hence, ANOVA will be the ideal. Because when you use ANOVA, your error will be within 0.05. By you using independent t-test, running it separately, your error will be more. So when your error becomes more, whenever you use independent t-test severally, we call it experiment-wise error. So the 0.15 that we have here is a typical experiment-wise error. And that's the definition I've provided when it comes to experiment-wise error. The rate of occurrence of type 1 error over series of individual statistical tests. So it means you use one statistical test, independent t-test, you run it separately or differently or severally, then you are committing experiment-wise error. So before we calculate or try and do any computation or solve any question under one-way ANOVA, there are certain assumptions we need to know. First, as I indicated, with one-way ANOVA, we compare more than two different groups. Again, whenever you are stating your hypothesis, there's a thumb rule, and this is something you need to know. Whenever you are stating your hypothesis, the hypothesis should be in a non-directional form. You know, under step 2, if you'll be solving using the full working steps or the 6 steps, you're supposed to state your hypothesis. The previous ones, you could either state it in a what? In directional or non-directional, depending on the question. But when it comes to ANOVA, always state your hypothesis in a non-directional form. Even when in the question, they have posed it in a directional fashion. Always state your hypothesis in a non-directional form. Another thing you need to know is that within the question, you could see that although they've stated the hypothesis in a directional form, they are telling you, oh, one of the groups will perform more or will perform better than the other groups. That's a typical directional. When you see it in that fashion, there's a high chance that you're supposed to do something known as post hoc analysis. And we'll talk more when it comes to post hoc analysis later. Also, with ANOVA, when we are computing, we compute to get a value known as F ratio. So like all the t-tests that we did, we normally compute to get a t-test value. But with ANOVA, the value that we are computing for is F, the F value. And the F value is the ratio of between group estimates to within group estimates. So we will delve more into what between group estimate and within group estimate is all about. Another key thing you need to know when it comes to the F ratio that you be computing is that always there's no way the F ratio should be negative. The value that you be computing, it shouldn't be negative. It should always be positive. The moment you calculate your F ratio and you realize that it is negative, that should signal to you that you made a mistake somewhere or there's something wrong with your calculation. Another thumb rule is that when your F ratio or the F value that you calculated for is large, then there's a high probability that you would reject HO. So for us to say that the F ratio is large, it implies that it is more than 1. When the F ratio or the value that you got is more than 1, then there's a high chance that you might reject HO. So let's try and solve a typical question when it comes to Anova. So the question that I have here, I'm reading. In a lab experiment on nature of words on recall, three groups of students were made to learn 15-item word list consisting of either neutral words only, taboo words only, or a combination of neutral and taboo words only. Okay. A combination of that. Each student in each condition learned the list to a criterion of errorless trial, and the number of errors made under each trial were recorded. The following data represent the average number of errors per trial for subjects in the various conditions. Okay, then the hypothesis that they were testing for. Test the research hypothesis that more errors were made under the taboo words only condition than under neutral words only and combination of neutral words and taboo words condition. So when you read the question, you could see that they were comparing three groups. Then you ask yourself, what is the dependent variable? What were they measuring? And per the question, they were trying to measure the number of errors committed by the subject. So it means the number of errors will be the dependent variable. And this dependent variable falls under what type of scale of measurement? It falls under ratio. Why? Because some subjects could, or some subjects, there's a high tendency that some subjects wouldn't commit any error. So it means there's a high chance that there might be an absolute zero. Hence, ratio is the best fit. So when you are able to deduce these two assumptions, they have more than two groups, or they were comparing more than two groups, and the dependent variable is on either ratio or interval, then it means you're supposed to use one-way Anova to solve. And the one-way Anova you have in there tells you that the term one-way tells you that we have one independent variable. Because with Anova, we have several types of Anova. But when it comes to this course, our focus will be on one-way Anova. So when you see one-way, it implies that we have one independent variable. So within the question, you could see that they indicated nature of words on recall. So it means nature of words is the independent variable, which is one independent variable. And they have manipulated the independent variable. When I say manipulated, it means they've divided the participant into several conditions or groups on the independent variable. So that's why we have 3 conditions. That's the sort of manipulations they've done. So they are telling us to show full working steps, meaning that we are supposed to state or use the 6 steps to solve. And that's the table they've provided for us. And one interesting thing about Anova is that when it comes, you could easily deduce, even you not reading the question, the moment you see the table, it could easily inform you that, oh, this question is Anova, because you could see that per this table, they have 3 separate groups: neutral words only, taboo words only, then neutral and taboo words. So when you realize that within the table, they have more than 2 groups in there, then that should give you a signal that you use one-way ANOVA. So with one-way ANOVA, it's quite easier for you to deduce it when it comes. So let's try and solve. First, we use the 6 steps, and currently you know the various steps. So the first step is choice of statistical test, meaning that we are supposed to state all the assumptions underlying ANOVA. And when you go through these assumptions, you can see that it is quite related to independent t-test. Most of the assumptions found here, you can find them within independent t-test. The only change here has to do with assumption 1 and 2. So with the first assumption, I indicated that we have 3 different groups or samples drawn from their respective populations. But you know, with independent t-test, we just indicate we have how many? 2 samples. But with this, since the groups were 3, I just spell out that we have 3 samples drawn from their respective population. And we were able to deduce that the independent variable was only 1. So that means it should be part of your assumption. It means within the question, only 1 independent variable was used. That's nature of words. Then you're supposed to also state the scale of measurement for the dependent variable, the scale of measurement for the dependent. And we were able to deduce that number of errors is on ratio. So that's what we've indicated. And as I've always been saying, when you are not all that sure, you are torn between ratio or interval, you can either indicate the dependent variable was measured on at least interval scale so that you'll be safe. When you put it like this, then it means you are telling the reader that, oh, the dependent variable could either be on ratio or interval. Then you state assumption 4 and 5. With that, you just assume, like what we did for independent t-test. We are assuming that the population means of the various groups, they are normal in form, or they are normally distributed. And the population means, again, they are homogeneous. That'll be for assumption 4 and 5. So after you've stated these assumptions, then you tell your reader that the best statistical test that will fit this question is one-way analysis of variance. And that will be all for step 1. So it means whenever you have an ANOVA question, this is how you're supposed to state step 1. Then the next step is statement of hypothesis. Like what we did for the previous test, we are supposed to state the null hypothesis and the alternative hypothesis. And as I've been saying, always you will get your alternative hypothesis from the question. So you can see that within the question, they provided an alternative hypothesis. They were comparing the 3 groups. They said taboo words only. That means this group, they will commit more errors than neutral words only. And combination of neutral words and taboo words. So it means the researchers, they have hypothesized that subjects who find themselves in taboo words only will commit more errors than subjects in neutral words only and neutral words and taboo words. Okay, so this is a typical directional hypothesis. And as I indicated earlier, although within the question, they put it in a directional fashion, when you are stating your hypothesis, you are supposed to put it in a non-directional form. So this is how we put it in a non-directional form. With H1, I just indicated there will be a significant difference among at least two of the groups in terms of number of errors committed. Then with HO, you just indicate there will be no significant difference among the three groups in terms of the number of errors. And one thing about Anova is that we don't represent symbols for H1. You just indicate symbol for HO. That's mu1 will be equal to mu2 will be equal to mu3. So if the groups are 4, you add mu4 to it. If they are 5, you add mu5. All right. Then the next thing will be step 3, which is decision rule. Decision rule. So under decision rule, like what we normally do for previous ones, we are supposed to first generate a critical value. Right now, we know we'll be solving for an F value. So it means we are supposed to solve for F critical. And for us to solve for any critical value, you know the things that we need. The level of significance, whether the hypothesis is directional or non-directional, then the degree of freedom. But with Anova, our focus will be on the level of significance and the degree of freedom. We use these two things to generate our F critical. And within the question, they didn't provide the level of significance. So we are assuming that our level of significance is 0.05. The next thing for us to do is to solve for the degree of freedom. And this is the formula for degree of freedom for Anova. Is degree of freedom for B. The B represents between over degree of freedom for within. And these formulas will be provided. So when you see DFB, its formula is K minus 1. Then DFW, its formula is N minus K. So one might ask, what is K? K represents the total number of groups. The total number of groups. Okay. And we were able to deduce that within the question, they were comparing 3 groups. So it means K will be 3. Then when you see capital N, it represents, capital N represents the total number of participants. The total number of participants in all the groups. The total number of participants in all the groups. That's what N or big N represents. And when you check the table, you could see that neutral words only had 7 participants. Taboo words also had 7, and both also had 7. So it means our big N will be 7 plus 7 plus 7. And that will give you 21. So it means for us to solve the degree of freedom, it will be 3 minus 1 over 21 minus 3. Because we had K to be equal to 3 and N to be equal to 21. So when we substitute this into the formula, we have to get a degree of freedom of 2/18. So currently we know that the level of significance is 0.05 and our degree of freedom is 2/18. Like what we normally do for the previous ones, we will use this information to generate our critical value. We will use this information to generate our critical value. So let me screen share the critical value table so that we can move on. So our focus will be on the table that they've indicated critical values of F, because we are solving for Anova and Anova is F. Okay, and when you check this critical value table, you see that they have V1. The V1 here represents the degree of freedom. You know, per our calculation, let me indicate our calculation for degree of freedom. We had it to be degree of freedom for between over degree of freedom for within. And with degree of freedom for between, per our calculation, we had it to be 2/18, which is degree of freedom for within. So it means this 2 here, or the V1 that you find here, represent degree of freedom for between. That's the numerator. Then the V2 that you find here represent degree of freedom for within. And per our calculation, we had degree of freedom for between to be 2. So it means you're supposed to read our information from this side. Then you ask yourself, which of the values should I select? Which of the values should I select? You could see that per our degree of freedom for within, we had it to be 18. So it means you're supposed to select this 18. And when you trace, it means you're supposed to select this value, which is 3.55 as your F critical. As your F critical. So it means our F critical will be 3.55. 3.55. All right. So since we know our F critical to be 3.55, we can go ahead and state the decision rule. And you remember I said when it comes to Anova, the F value that we want, always it should be positive. So it means we don't need to state the negative decision rule because we wouldn't need it. So it means we will state only the positive decision rule. And that's the positive decision rule. It means we are comparing our F observed with the critical value. And you know how we state the positive decision rule. So after you've stated it, then you move on to step 4. Step 4. And at step 4, that'll be where we'll compute for the F observed. And the formula for F is mean square for between over mean square for within. Mean square for between over mean square for within. Then you might ask yourself, so what is mean square for between? All these formulas will be provided. So the formula for mean square for between is sum of squares for between over degree of freedom for between. Then mean square for within will be equal to sum of squares for within over degree of freedom for within. So it means for us to solve for the F value, we first need to solve mean square for between. And they've given us mean square for between, the formula. And when you check the mean square for between, we already know degree of freedom for between. Because when we are solving for degree of freedom, we said degree of freedom is equal to degree of freedom for between over degree of freedom for within. And we had the degree of freedom for within to be k minus 1. So it means we already know degree of freedom for between. The same thing applies to degree of freedom for within. We already know it to be n minus k. So it means for us to solve mean square for between, we are tasked to find sum of squares for between. Sum of squares for between. And the formula for sum of squares for between is this. That's the formula. And please don't be intimidated about these formulas. They are quite simple and it's related to the independent t-test, what we did. You remember I said with independent t-test, whenever you see these subscripts, it just tells you that subscript number 1 is for group 1, then number 2 is for group 2, number 3 is for group 3. So you can just ignore the subscript. It means you're supposed, when you check sum of squares for between, basically what they are telling you is that solve for this sigma x squared for all the groups. That's what basically this formula is all about. This formula here, the one in the first bracket, that's what basically they are telling you to do. Solve sigma x squared for group 1, 2, and 3. And you know how to solve them. So I'll delve more into the next notation here, the sigma x all squared over n. We'll talk about it later. Then with sum of squares for within, that's the formula, like what we did for sum of squares for between. Basically, they are telling us to solve for sigma x all squared for all the 3 groups, and also sigma x squared for all the 3 groups. So this implies that they wanted to solve for this one. Then when you see this, it implies that they want us to solve for this for all the 3 groups. That's what basically we have to do. And we've already solved these things, or you know how to solve these things. So it means with this, you need to first score the x values. You need to first square them. After you've squared, then you sum. Then with this 1 in the bracket, it means sum the x values. After you've summed them, then you square. So let's try and do it. So it means we are supposed to find sigma s squared. So it means we need to square these x values for neutral words only. And when you square, that's what you get. Then afterwards, you add. So sigma s squared will give you 88. Then you do the same thing for the other groups. We'll give you 323 and 139. So that will be for this notation here, or this notation here. That's what we are solving. Then the next thing is for us to solve sigma x all squared, the one in the bracket. We are supposed to find it for the 3 groups. And as I said, ignore the subscript. It means solve sigma x all squared for the 3 groups. So in math, when you see something like this, it means solve the one in the bracket first. And we've already solved it to be 24. So we have 24. So it means 24 squared, that'll be for group 1. Then 47 squared, that'll be for group 2. Then 29 squared, that'll be for group 3. So that's what basically you need to solve. Okay. So let's try and substitute them. We are solving for sum of squares for between. And under sum of squares for between, we know the value, we know the formula. And currently we know sigma s squared to be 88. Sorry, we know sigma s all squared to be 24. So it means it will be 24 squared plus 24 squared over n1. N1 represents the total number of participants in neutral words only, which is 7. So it means it will be 24 squared, which is this over 7, plus 47 squared, which is this one, squared, plus 29 squared, which is for group 3. All over so the next one that we need to do is to solve for this, which is sigma x all squared. And when it comes to this, it means that we are supposed to find, or we are supposed to add sigma x for group 1, 2, and 3. Then afterwards, we'll square. We are solving for sigma x all squared, which is this here. What it implies is that we are supposed to add sigma x for group 1, sigma x for group 2, and sigma x for group 3. So it will be 24 plus 47 plus 29 all squared. And 24 plus 47 plus 29 will give you 100. And 100 squared will give you 10,000. Meaning that this area, which is the numerator, is supposed to be 10,000 over n. And you know n to be the total number of participants in all the groups, which we had it to be 21 because we had 7 participants each. So 21. So after you've done these, then you solve. And when you solve, the final value that you have for SSB should be 41.80952381. And one thing about this course is that when you are calculating, don't round it. Don't be hasty to round. The only time you round is when you've gotten your final value. And right now, you know the final value that we want. We want F. We're going through all these hassles. It's more or less like we are trying to find F. We haven't found F yet. So it means whatever value that you would generate on your calculator, indicate it the way you see it on the calculator within your answer booklet. Okay. So right now we know sum of squares for between. The next thing for us to solve is sum of squares for within. And on a sum of squares for within, let me try and copy this table so that it will help us well. So on a sum of squares for within, so this is a table. And this is the formula for sum of squares for within. It means you're supposed to find sigma s squared. We've already found sigma s squared for group 1, 2, and 3. So it means it will be sigma s squared, which is 88, minus sigma x all squared, which we had it to be 24 squared. And 24 squared should give you 576 over 7. Minus plus, then we'll go in for the second group, which is sigma x squared, which is 323 minus 47 squared will give you 2209 over n2, which is also 7. Then plus this, 139. So we are solving for this, which is 139 minus 24 squared, which will give you 841 over N1, which is 7. And when you solve, you are supposed to get a value of 32. You're supposed to get a value of 32. So currently we know mean square, we know sum of squares for between, and we know sum of squares for within. So we can easily solve our mean squares. And per the formula for mean square, we had it to be mean square for between to be sum of squares for between over degree of freedom for between. Currently, we know sum of squares for between to be this value. Let me present it here. We know the sum of squares for between to be 41.8095. And we know that our degree of freedom, we've already solved for our degree of freedom for between. We had it to be 2. So it means that the mean square for between will be 41.8095 so over 2. And when you calculate, you're supposed to get this value. That's 20.9047 and so on. So that will be for mean square for between. Then the next thing for us to do is to solve mean square for within. And that's the formula. Sum of squares for within over degree of freedom for within. We've been able to solve sum of squares for within. We had it to be 32. We know our degree of freedom for within to be 18. So it means our mean square for within will be 32 over 18. And that will be the answer. So currently, we know mean square for between and mean square for within. Hence, we can solve for f. So f is equal to mean square for between over mean square for within. Currently, we know the values. And we know mean square for between to be 20.904761 over our mean square for within value, which is 1.7777 and so on, 8. And when you calculate this, you're supposed to get this value, 11.75892857. And when you round this value into 2 decimal places, you're supposed to get an F observed value of 11.76. So that's the final value, 11.76. So that's our F observed value. So that'll be all for the computation. So after the computation, then the next step we are supposed to do is to make a decision. And like what we normally do for the previous ones, you're supposed to compare this F observed value with our critical value. So let me copy the critical value that let me copy the decision rule that we made. We are supposed to compare our F value with our decision rule. Per our decision rule, we indicated that we are supposed to retain HO if our F observed is less than 3.55, or reject HO if our F observed is greater than or equal to 3.55. Currently, we know the F observed, right? We know the F observed to be 11.76. And when you compare 11.76 with 3.55, 11.76 is greater than 3.55, meaning that we are supposed to reject HO. So when you are able to deduce this, then this is how you put it in writing. Under step 5, this is how you put it in writing. You tell your reader that you compared the F observed with F critical, and you found out that the F observed, which is 11.76, is greater than 3.55. Therefore, you have to reject HO. Okay. So since we are rejecting HO, then it means we'll move on to the next step, which is interpretation. And our interpretation, as we've been doing for the previous one, we are supposed to select one of the hypotheses. We are supposed to select either H1 or HO. And for us to select any hypothesis, it will be based on the decision that we've made. We've made a decision to reject HO. It means that the only hypothesis available to us is what? H1, meaning state what you indicated for H1 under step 2. And when you go back under step 2, we indicated that there will be a significant difference. So it means your interpretation will be there will be a significant difference, or there is a significant difference between at least two of the groups in terms of the number of errors committed. That'll be your interpretation. Another thing you need to know is that after you've stated the interpretation, this interpretation, go back and find out, did they put the hypothesis, I'm talking about the question, did they state it in a directional fashion? Right now, you've rejected HO and you've indicated that there is a difference existing between the groups. But the calculations that we did didn't specifically let us know as to whether the difference we are talking about, it exists between only one of the comparisons or all the comparisons. So if you realize, I indicated that when your groups are 3, it means that you'll be doing how many comparisons when it comes to Anova? 3. So for instance, we have 3 groups. It means that Anova will compare neutral words only and taboo words only separately. Then we'll compare neutral words only and both conditions separately. Then we'll again compare taboo words only and both words separately. So it means we will have 3 different comparisons. But the calculations that we've done so far, the F value that we got, it wouldn't really specifically let us know where the difference lies. Does the difference lies between only neutral words only and taboo words? Or the difference exists between all the 3 comparisons? So the F value wouldn't let us know whether the difference exists between only one of the comparisons or 2 of the comparisons or 3 of the comparisons. So when it happens like that, then it means we are supposed to do further analysis. And the only time you do further analysis is when your hypothesis was stated in a directional form in the question. They put, or the researchers hypothesize it in a directional form. And per your interpretation, you were able to deduce that there is a difference. Then it means that you're supposed to do further analysis known as post hoc analysis. Post hoc analysis. So we will delve more into post hoc analysis later, and another video has been uploaded when it comes to post hoc analysis. So you can watch the video, and please don't forget to subscribe and also click on the notification button so that you will get information about subsequent videos, because I've uploaded the post hoc analysis video, and I would also be uploading tests on Pearson and Spearman. So don't forget to click on the notification button so that whatever video I upload, you would have notifications on that on your device to watch. Thank you. So that'll be the end of today's discussion.